Let's do a problem. A father and his son celebrate their 39th and 10th birthdays on the same day. We have to form a linear equation between their age and use the equation to form a linear equation for Part 1. Find the age of son in terms of his father's age n years after. Part 2. Find the age of father in terms of his son's age before m years, m is less than 10. Let's discuss the approach for doing this question. A linear equation has at least one variable. It can have more than one variables also, which correspond to unknown quantities. Let's see which are those quantities which will correspond to the variable here. Assume that son's age is x and father's age is y. Can we say here that x plus y is equal to 39 plus 10, 49, and say that this is our required equation? Let's see if this equation is correct or not. Let's consider their age after n years, and if we take n is equal to 5 here, then after 5 years, age of father will be 39 plus 5, that is 44, and age of son will be 10 plus 5, that is 15. Is this, that means 44, 15, the solution pair for equation x plus y equal to 49? We can see that this is not the solution pair. 44 plus 15 will be 59, and here we have 49. So here x plus y equal to 49 is not the right linear equation. It is only true on that day when father and son celebrate their birthday on the same date. So we need to find that linear equation which is true for any point in time. How do we do this? Let's look at the age of son and father after each year up to 5 years. So after 1 year, age of son and father will be 11 and 40 respectively. Like this, we have shown data up to 5 years. After 5 years, age of son and father will be 15 and 44. We have to find a linear equation for which these are the solution pairs. What could be such an equation? Here we will use a type of linear equation in two variables. Y is equal to mx plus c, where c is the constant and m gives us the idea of how y varies with x. This graph has been plotted with these solution pairs, and we can see in this graph, when x increases by 1 unit, y also increases by 1 unit. Therefore, this m here will be equal to 1. So our equation can be y is equal to, in place of m we can write 1, x plus c. This implies y minus x is equal to c. Now we need to find this c, and we can see here that whatever be the solution pair, difference between y and x here is 29. So 40 minus 11 is 29, 41 minus 12 is again 29, and same can be done for all the other solution pairs. So c here comes out as 29. So this implies our equation is y minus x is equal to 29. This linear equation in two variables here is true for all values of n or m in future or past. In the first part, after forming the linear equation, we have to find age of son in terms of father's age. So on rearranging the terms here, we will have x is equal to y minus 29. This expression of son's age in terms of father's age is for n years after the day when the father and the son celebrated their birthday together on the same date, and value of n can be anything here. Also, the second part, age of father in terms of son's age before m years, where m is less than 10, this is asked in the second part, will be, once again rearranging the terms in this equation, we will have y is equal to x plus 29. In this question, we summarize the relationship between two quantities using variables such as x and y. The form y is equal to mx plus c can be used to form the linear equation when m gives idea of how y changes when x is changed.